Hey all you cool cats and kittens out there, it's Ian Allred. Going to go through separable differential equations, some more examples. I recorded this video earlier and found out that the sound was off. So if you find another video where the sound is off, please let me know. But we're going to walk through dy over dx equals the square root of x times y. And what we're going to do is we're going to solve that for, first of all, a general solution and then a particular solution that goes through x equals 0, y equals 9. So the first thing to do is realize that x, y is under the square root. So we can't separate them easily, but if we use some of our properties of exponents, we'd know that that quantity is to the 1/2, and we could eventually rewrite it as x to the 1/2, y to the 1/2. And if we divide through by the y term and multiply through by the dx term, we'll get 1 over y to the 1/2, which we'll bring up as y to the negative 1/2 times dy equals x to the 1/2 dx. So y is on the left, x is on the right. They're not mixed up. So we can easily integrate both sides. With that, on the left, we get 2 y to the 1/2 equals 2/3 x to the 3/2 plus c. Once again, that was a c on both sides that we combined into a single c. We can divide by the 2 here to get the coefficient in front of the y term gone. I did this right here because if I divide c by 1/2, since c is a constant, dividing it by 1/2 is still a constant, so I can still just call it c. I don't have to keep the 1/2 or divide by 2 there. If I wanted to keep this as a general solution, I'd probably square both sides, which is not a bad idea. But because I'm going to throw in and solve for c when x is 0 and y is 9, I'm just going to leave it as is for now, because I don't want to pick up extra solutions. So I plug that in, x is 0, y is 9. Plug it in, balance out the equation, I get c is 3. So finishing this thing up, if I plug that c in, I'd have the square root of y equals 1/3 x to the 3/2 plus 3. But if I want to get y by itself, it's not too hard in this particular example. I can say y equals the quantity squared of 1/3 x to the 3/2 plus 3. Okay. Let's do a second example as well. Alright, let's go to another example since we haven't used too much time. The second example, we've got another separable differential equation. On the left hand starting out, we've got cosine y plus 2 times dy over dx, basically a y prime, equals 2x. Then we've got an initial condition of y of 1 equals 0, and we're eventually asked what is x when y equals pi. Well, let's first of all find a general solution for what we've got. So we want to separate the dy dx so that all the y's are on one side and all the x's are on the other. So all I have to do is multiply both sides by dx. That gets rid of the x's on the left and puts it on the right. So then I can integrate the left and right side easily because the complete left is in terms of y and the complete right is in terms of x. So integrate cosine to sine 2 becomes 2y, because that's the variable we're integrating here. 2x becomes x squared. Once again, there's a c on both sides, but we'll combine them into a single c. One thing that's worth noting here is because this y is in the sine function and this y is by itself, would not be very easy to get an equation that looks like y equals. So sometimes, a lot of times, that's would be very difficult. But we've got a general solution. So then we'll use our initial condition of y of 1 equals 0 to find c. So when I plug in 0, of course the sign of 0 is 0. I get that c is negative 1. So the particular solution is sine of y plus 2y equals x squared minus 1. Still would be difficult to get y by itself. So that's the way I would leave that particular one. And if you're working some problems and looking at solutions to check yourself, if they always get y by itself, it may be a stretch to figure out how they do that. But it should be possible. Last thing on this problem here, you're going to plug in pi for y and solve for x. So sine of pi is also 0. So if we get the x term by itself, which is x squared, it'll be equal to 2 pi plus 1, but we'll take the square root of both sides. So we get a plus or minus square root of 2 pi plus 1, which is not a pretty answer. I'll save the other examples for a separate video to keep them short.